Hello everyone, Axie from the Wingbits team again. This video will be covering optimizing your setup's gain using Graphs 1090 and a command line tool on your device. As always, please pause and check for a pinned comment before continuing. If anything has changed or an update was needed, we'll call it out there. So prerequisites for this. You have to have a running setup, which means it's showing online already on the Wingbits dashboard. Ideally, you'll want to have had the setup working for a couple hours, but a day would be better as a baseline. You also don't want to do this late at night. You want heavy traffic hours like between 8 a.m. and maybe 6 p.m. for your time zone, because if you do this during low traffic hours, it'll result in poor optimization. You don't want to waste your time. So what is optimizing gain? Well, your ADSB receiver likely has an amplifier built in. Most of the commonly used ones do. The gain setting allows you to turn up the amplifier if incoming ADSB signals are too weak. It also allows you to turn it down if the incoming ADSB signals are too strong. The best example is to think of it like a home stereo system. If it's too low of a volume, it's going to be hard to hear the music. If it's too loud of a volume and the speakers start to distort, it makes it hard to hear the individual sounds as they were intended. I know it's not a perfect analogy, but it probably makes sense to most people listening. There is an ideal volume in this case where you can hear every note, but the speakers aren't distorting. This is basically what we'll be doing with your gain on your setup, making sure that your ADSB receiver hears as many aircraft messages as possible. And to address it now, since some are probably curious, why can't I just use the autogain script on GitHub? Well, that depends. Do you care about getting the most rewards possible for your setup, or are you okay with it just being maybe 80% of the way there? If you don't care about maximizing, just install this, close the video, and go spend time with your family or your pets or whatever. Seriously. Okay, well, if you haven't left, then you're still here because you care about maximizing your rewards. Don't use the autogain script. If you installed it previously, uninstall it. You can scroll down here and there is a removal deinstallation command. You can copy that and paste it into your SSH window for your Pi, and it'll uninstall. I do mention uninstalling because if you installed it ever, even just to run through some quick tests, and you didn't uninstall it, it'll keep running in the background and change your gain potentially every night. We don't like that. I don't like that. Nobody wants to have a system change on you in the middle of the night. It has led to multiple people having confusion where their stats were going down and they couldn't figure out why. It turns out autogain was helping them. So how will we set the gain? Well, we have a FAQ page on the docs site. And if you scroll down to Wingbits configuration, there is how do I change the gain? Expand that and you'll see, I'm going to read it for you. You can change your gain using the following command. You're going to replace the X's with a valid gain number. But note the command will not output anything once you run it, unlike the location command, which does show you your location back. Command is simply sudo readsb-gain, and then the number you want to change it to. There's a list of valid gain numbers here that are allowed. If you type any other number, it's just going to go to the closest one. So if I were to type in 20, it's going to go to 19.7 because that's closer than 20.7. I find it easier to put in an actual value that you intend, one that's listed on here. You'll note at the end there's a -10 option. That essentially sets the gain to 58. For the majority of setups out there, your ideal gain will probably end up being somewhere between 43.4 and 49.6. So one of these 5 values. This minus 10 we mentioned, so that's what's called AGC, or auto gain control. The problem with that setting is that these types of receivers were originally meant for all kinds of things like radio or television signals, which are single sources and would have like a steady transmitting power. Since aircraft are all over the place above you and they're at different ranges, the signals come in at different power levels. Plus, their messages are short bursts as opposed to a continuous signal. So auto gain control, or AGC, also again minus 10, won't work with ADS-B as intended. It'll basically trick the receiver driver into allowing a gain value above 49.6. And again, it's effectively like setting it to 58 or so. I've seen in the docs or in the code that it says 59 as well. But this gain level is basically wide open, and it's usually too high in almost every single case. So don't let it stay at minus 10. It is the default when you install it. So now you know where to find the docs and the values you're allowed to use. You may be asking, how do I know what to set it to? Good question. So to figure that out, we're going to use graphs. I'm going to do a quick explanation of graphs 1090 and what these charts actually mean. I'm also going to use another unit that's been running properly for the purposes of explaining the graphs. So that way you see more realistic data. I'm going to set this to 24 hours. You may note, hey, you're running in dark mode. There are instructions on the Graphs 1090 GitHub page to change the mode to dark mode. You're going to edit one file and change one value in there. If you're not using dark mode, your line colors will be different, but you can figure that out based on the names and the colors that you see. Also, you will notice use of ADSB-B in most of the names for these charts. For anyone curious, B stands for broadcast. And finally, you should be aware that there's multiple types of ADSB messages. So TAR 1090 and these charts typically reflect overall message counts. Some areas have a process where they interrogate all flights around them to basically request a check-in message. That's a different kind of message. This means that those areas may have really high message rates compared to what you might see in your area. So for example, if you're in Discord or something, don't compare message rates of someone in the UK if you're in the US. Europe is another area in general where interrogation happens and message rates will be higher. The positional messages are the ones that you see reflected in your Wingbits dashboard charts. Those are the messages that also include latitude, longitude of the craft, along with many other things, heading, speed, and so forth. Those are the ones that are important to us. Those are the ones we're going to focus on. So one of the most important graphs is the top one. It is bigger. Makes sense, right? But it is for us too. So to explain this, first thing you see is messages received. This is all the messages you decoded, positional messages or not. The min and max, you'll see this in the 7-day average only for certain tabs. Note at the top, we have different time range tabs. If you're under a certain value, you may see these. If you're over a certain value, you may not. Both the min-max and the 7-day average indicate what's happened in the past. Gives you a good idea if something has happened recently. Like if you notice that your messages received line is way below your min-max or your 7-day average line, chances are there's been a hardware problem, like your antenna's been knocked over, something else has happened, a cable issue, water has seeped into a connector. You've got something going on. Generally, you will see these lines within this min-max range. Your messages greater than -3 dBFS. This shows a percentage of messages that were really high or loud, if you will, possibly too high. I'm going to call these hot going forward, so hot messages. This is the first thing that matters when we're tuning our gain. Ideally, this should be 10% or less in almost all cases, and possibly under 5% for many other cases, but we're going to talk about that later. The last thing on here is positions per second, and then RHS. So these are the positional messages that currently mean the most for Wingbits. They're messages that aircraft send out typically every half second, giving all the important positional message we talked about before: latitude, longitude, altitude, heading, speed. You may have been curious what RHS means. It's actually on a few different charts here, a couple different charts. You'll see it when there is a right-hand side y-axis. You'll notice on the left here that the messages per second, it goes up to 1200, from 0 to 1200. But on the right-hand side, you'll see 0 to 120. That's because it's 0 to 120 positions per second, which is on the right-hand side. You want these positions per second to be as high as possible because it means you're collecting more data for the project. Next chart, aircraft seen. It can be fun to look at. Just a quick run through. Aircraft seen or tracked, it should be obvious. It's just aircraft seen or tracked. Average and maximum. These two are just some quick stats. It's only pertinent to the current time period you have selected, 24 hours in our case. ADS-B position. So these are planes that sent positional messages. MLAT position. You shouldn't see any of these as we don't have MLAT enabled at this time. Maybe later. Again, check the notes of the pin message of the video. Maybe that's changed. TIS-B. So if you're in the US and you're near an ADS-B ground station, these are messages that might be relayed to you about aircraft. Those are generally aircraft that don't run ADS-B out. And then finally, without position, these are planes that aren't sending out positional messages at all. We would need MLAT to figure out where they are. MLAT is multilateration, basically uses many antennas to calculate the position of a flight. Kind of think of like triangulation. Next chart is track seen. It's basically not important to us. Ideally, you want tracks with greater than one message to be the majority of the chart, not the ones with just a single message. That said, apparently the tracks with a single message stat is not likely an aircraft with only one message, but a corrupted message. That's according to the creator. So you'll see in this chart, I've got a lot with more than one message and a few with a single message, which again could be corrupted messages. Next chart is ADS-B range. Not super important overall. It is sometimes useful to indicate how solid your physical install was done. If you have an indoor antenna, this will be lower than someone with a well-placed outdoor one. Someone with a really high dBi antenna may get a further range, but they're also missing some overhead flights in exchange. Don't do this. Use a 5 to 6 dBi antenna, please. It's going to serve you better. Unless you're in a very unique situation where there's no nearby flights and the only ones you can catch are further away. In that case, you might want to move to a higher dBi antenna. Some people use 8 dBi in that case. It's very circumstantial. All that said, the higher you set your gain on ReadSB, the further your range is going to get, but it's also going to increase your hot messages, which we don't want on the top of the chart up here. Don't fall into the trap of trying to max out your range. It's more important to observe other things, and your ranges will just be a result or an outcome of your optimization. Signal level. This is a super important graph to us, but really just for one value. Some of the other values are kind of handy to look at for reference, but the value we care about the most is weakest. It can look, I'll be honest with you, it can look really crazy if you're in a low traffic area, or maybe if you're using an antenna indoors, or also if you're looking at it during off hours and you have a really short time span by using the tabs up top, like a 2-hour tab. So another reason why you shouldn't try to do this and change your gain and adjust it during off hours. Do it when you have the most amount of traffic you typically would. But real quick, the first to third quartile, that's where 75% of your received messages come in. This is going to be above your weakest line, obviously. Sometimes noise will go into that first to third quartile area, and that's okay. Noise is basically all the non-ADSB messages you're receiving. Those can be cell phone, LoRa messages, really anything else that's being transmitted around you. You're going to have it no matter what. You can't get rid of noise. Noise is going to be there. Median and peak really aren't important to us, so I'm going to skip over them. ADSB maxima. These are just the maximum values seen during the currently chosen time period for each of the items. It's cool info, but we're not going to discuss it any further because what you see as the highest amount for just a moment in time isn't a really good indication of your overall performance. So this is ADSB message rate per aircraft. It's mildly interesting, but not for setting your gain. This is more about how many messages you get per aircraft on your setup. The averages are simply the number of messages per second divided by the number of aircraft you're seeing in that second. It's not really tracking like messages for each individual aircraft and trying to calculate it. The higher numbers are better, but again, in certain areas, interrogations can affect that. In other areas, it's just based on how many flights you have and how far away they are. You may only have stuff in range for a short period of time, so your numbers may be lower. These stats can be an okay reflection of your antenna placement and of your line of sight. By that, I mean, if you see a lot of flights, but your messages per second seem low compared to others in your country or your area, chances are you have some obstacles that cause you to lose track of the aircraft and then regain them over time. Some people may have seen this on TAR 1090 where the track for a craft has a dashed line. It means you lost track of it for a short period of time. Probably an obstacle between you and that flight. We're going to ignore CPU utilization. Last one here is miscellaneous. This only shows your gain. If you don't see this chart, you can restart the Graphs 1090 service or just run the Graphs 1090 install from GitHub. Remember, we had that over here, Graphs 1090. You can run this command again on your command line and it will reinstall, which will also restart the service for you. And that will get the chart showing up again. Oops, we're on this page. This chart can be handy to see your current gain without going to the command line and getting it. It also is handy to line up with your changes over time to your gain, along with the other charts you see on this page. You'll be able to compare the results of those changes and see how it impacted. All the rest of the charts down below are hardware related, operating system. I'm not going to go through them. They should be fairly self-explanatory. Now that we've talked about all the different graphs, how do we actually optimize? Well, it's going to be a bit of trial and error, honestly, with some reasoned choices based on the data that we see. I'm going to switch back over to my test unit. And our initial changes are going to be based off of two values and could be considered more of a broad adjustment than a finer adjustment. We'll do the fine adjustment later. Now we just want to get in the right range. So change your tab up top here to the 2-hour graph period. Again, can't hammer this in strongly enough. Do this during busy traffic hours. Typically in your area, it's going to be somewhere between 8 a.m. and maybe 6 p.m. If we do it outside of that window, we will be optimizing for the wrong flights and it won't work as well as we'd hoped. So let's focus on the signal graph first. Signal level. Your goal should be for the weakest number to be between minus 26 and minus 32 dB. So that's going to be right about here down to here. As you'll note, it says our weakest is 21.1, but we're somewhere right under minus 18. So we want to move this line down between that minus 26 and minus 32. If you're just above at minus 25 or just below at minus 33, still try to move the gain into the range I mentioned. But this will depend on your hardware, so I can't give you just one target of like minus 28. Some hardware setups will result in your best option being minus 26, while others may result in the best setup at minus 32 or anywhere in between. Again, note that the default gain is minus 10, AGC we talked about before. So your signal chart might be really squished up near the top. For this test unit, I have set it to minus 10. As you can see down here, it says the gain is 59, also known 58, also known as minus 10. This is wide open maximum. You'll notice that this chart's kind of squished. There's not a lot of headroom between the peak and the first quartile blob here. What you want to do is if your weakest signal is above minus 26, you'll want to lower your gain. For us, it is above that. Above is closer to 0. So you can look on this chart. If you try to remember if above and below which direction it is, it literally means above, but that doesn't mean the higher number. So we are at around minus 20. We want to move it lower to down to under 26. So we want to lower our gain. If our weakest line was down here at minus 40 or something, we would want to move it up, which means increasing our gain. So as a general rule of thumb, if your weakest number is, let's say, minus 40, and you want to increase it to somewhere around minus 30, try increasing your gain by about 10 points, which is what we just said, minus 40 to minus 30. We want it to go up about 10. So change your gain 10 points. If you're trying to move it down similarly, like from minus 20 to somewhere in the minus 26 or lower range, we might want to drop it about 5-6 points at least. If you remember on the FAC, we're at minus 10, which is basically 58 or 59. Our next one down is about 10 points lower. It's 49.6. So we're already going to be dropping it 10 points. So we're going to probably end up shooting for around minus 30 if we drop minus 20 to minus 30. So I'm going to change to putty. You can do the same thing, SSH into your Pi, same way as you did during the install, using like putty or terminal or termius or the command prompt, and using either your IP or the host name to get there. I'm already connected and at the command prompt in my home directory. I'm going to update gain to 49.6. And just like you might do, I am going to copy. I think I just made a copy sound. Did you hear that? All right. I'm going to copy this to my clipboard. I'm going to right click or shift insert to paste. Obviously we don't want to use the XX. So I'm going to say 49.6. I'm going to hit enter. As I said before, there is no output. It just goes back to the command prompt. What we will notice is over time, this should update to a new gain. Now you are going to have to wait probably 5 minutes or so to get a good visual change on the 2-hour chart. Again, make sure you're on 2 hours. So 5 to 10 minutes, and then we can adjust it again if needed until we get dialed into that -26 to -32 range. I'm going to stop the video now and come back in 5 minutes and we'll see where we're at. So we'll note that it's been a few minutes and the gain has dropped to 49.6. It has also dropped our signal level to -27, which was in our -26 to -32 range. If it hasn't dropped enough or it hasn't risen enough, you may need to drop your gain another step or raise your gain another step. But once it's within that range, you're going to want to let it run for about 2 hours before the next step. If that puts you outside of your busy air traffic times, I'd suggest revisiting this the next day when the traffic is heavy again. But let's assume you're still good and that you've waited about 2 hours. If we were to come back after 2 hours, this 2-hour chart will have moved this red off to the left and we wouldn't see it anymore. That red, again, is your hot messages. Your message is greater than -3 dBFS. So what's a good number for this percentage here? The rule of thumb is around 5% or lower. Sometimes it's okay to be closer to 10%, such as if you have line of sight to an airport or you're close to one, or even if you're under major air traffic highways. Now, after 2 hours, if your percentage is still like 15%, 20%, or even higher, you will need to lower your gain. There's no rule of thumb here on how much to lower it based on what percentage you're at. But if somehow your percentage is really high, like 30%, I would try larger gain drops than just a single step. Or you're going to be at this for a while. Your ultimate goal is to keep this signal level above -32 and below -26 and get this message percentage somewhere between 0 and 10%. Once you have those two numbers in a good place, we want to try and fine tune for increasing the positional messages per second. Again, positional messages are the right-hand side. In this graph, you'll see it right here. We want that to be as high as possible. This is, as you can see right now, going to change based on how many flights are in the air around you. I am getting later in the day. It's 6 p.m. So that may negatively impact us being able to do this perfectly. But the goal here would be to change the gain by only one step up or down at a time. You're going to try it up first and see if we can increase our positions per second in the first graph. If we up the gain by one step, we're going to wait 5 minutes and see if there's a jump to this bar. You'll see it. It'll be a jump. Instead of a nice even move, it'll be a big bump up. The challenge is if you're already at 49.6, such as we are, and your weakest and hot messages numbers are in the right ranges, chances are moving to -10 will push you out of the ranges and your positions per second will go down actually. If you're lower than 49.6, it's likely worth trying the next step up as mentioned. So if you had moved it down to 48 to get it into this good weakest range, you might be able to bump it up to 49.6 and see if you still fall in the ranges. Let's switch over to my active station instead of the test station for a 2-hour chart period, and you can see what we're shooting for. Ideally, just to hammer it home, our weakest is above -32 and below -26. I'm right barely in that sweet spot. And my hot messages are under 10%. In my case, 4.2. This is ideally what you want. You'll notice there's a lot of headroom above the first to third quartile up to the peak. You'll see all this blank area. My noise is fine. It's just barely bumping into these quartiles. You may also note, if I scroll down, that the gain on here is 49.6, which is the same gain I set on the other unit. They're completely different dongles. And I have noticed that with a FlightAware dongle, that 49.6 results in a higher weakest value, even if I have an external filter on. Let me show you a 30-day. So on a 30-day, this is a FlightAware non-filter on board dongle and an external ADSB exchange filter. You'll see that the weakest was much higher. It was at -26, I think, but it still worked really well. When I switched to test a radar box with onboard filter, no external filter used, at the same gain level, my weakest is much lower. I would ignore this weakest being 35.3 because that was a blip on there. But this is now around -32. And I'm receiving more positional messages. And you might be able to tell that in the positions per second. See week 11 and how this was higher than what the average is over here. So there are differences between the devices. It's just a matter of testing different values methodically using the stuff we discussed. If you do have any additional questions, if something was unclear in this video, please join our Discord and ask. We have a channel dedicated to setup discussion where we or the community can help you gauge your current setup. Just post your graphs. Typically these top ones, don't bother going into system graphs. Just post, say, 2 screens worth, all these charts, and then scroll down and screenshot these charts. Post those in the channel. I would also suggest using the 24-hour tab so we can see your low traffic and your high traffic times and figure out what you need to do. Anyways, I hope all this helped. And that's all for now. So take care and we'll catch you on the next video.